Hey everyone, in today's video what we're going to do is solve the limit as n goes to infinity of n plus 1 raised to 1 divided by n plus 1 minus n raised to 1 over n. Now we're going to do this by splitting the limit up and applying a smart transformation to each of the limits and then using L'Hopital's rule to solve each of those limits. So let's begin by splitting the limit up. Doing so, we have the limit as n goes to infinity of n plus 1 raised to 1 divided by n plus 1 minus the limit as n goes to infinity of n raised to 1 over n. Focusing on the first limit, what we're going to do is raise it to e raised to the natural logarithm. Now this doesn't change the limit because e raised to the natural logarithm of anything is just equal to anything. So for example, e raised to the natural logarithm of x is just equal to x because they're inverses of each other, so they cancel each other out. Now, using the continuity of the exponential function, we can actually move the limit inside it. So we now have e raised to the limit as n goes to infinity of the natural logarithm of n plus 1 divided by n plus 1, where we've just brought the exponent down to the front using the power rule for the natural logarithms. Now, notice that this limit is actually of indeterminate form, infinity over infinity. So what that means is we can apply L'Hopital's rule to solve it. If we take the derivative of the numerator, we just get 1 over n plus 1 multiplied by the derivative of the argument of the natural logarithm, which is just 1. And if we take the derivative of the denominator, we just get 1. So we're left with e raised to the limit as n goes to infinity of 1 divided by n plus 1. And if we let n go to infinity, the limit just evaluates to 0. So we have e raised to 0, which is equal to 1. So that's the first limit solved. Now, we solve the second limit in more or less the same way. We have the limit as n goes to infinity of n raised to 1 over n. Applying the same transformation, we see that this is of indeterminate form, infinity over infinity. Taking the derivatives, we get e raised to the limit as n goes to infinity of 1 divided by n. And again, if we evaluate this limit, it just evaluates to 0. So we get e raised to 0, which is equal to 1. Now putting this all together, we get that the limit as n goes to infinity of n plus 1 raised to 1 divided by n plus 1 minus n raised to 1 over n is equal to 1 minus 1, which is 0. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe? If you've noticed any mistakes or you have any questions, make sure you leave them in the comment section below. Anyway, that's all for now. I hope you have a great day.